Alright, what's up guys? Welcome back to another video on Double A Learning. Today we're going to be focusing on L'Hopital's rule. It's a fundamental topic in calculus. I touched on this topic a little bit on my limits video, so if you guys want to just get a brief summary, you can check that one out. But here I'll be going more in depth, I guess, on L'Hopital's rule. So, alright, let's just right off the bat, what is L'Hopital's rule? So it's basically like a tool that's used to evaluate limits when they're in the form of either 0 divided by 0 or infinity divided by infinity. Essentially, there's undefined values in the numerator and denominator when you're solving a limit. So let's take the example of limit as x approaches 0 of sine x over x. Alright, this is our first limit we're going to do. So let's use our standard limit theory. So first thing we do right away, plug and chug, right? So let's plug in what the x value we know. So sine, we're saying x of 0. We know sine of 0, that's just 0. And we know when x is equal to 0, that's just 0. So this limit, when just plugging and chugging, gives us 0 over 0. Well, according to L'Hopital's rule and all limit theories, if you have 0 over 0, that's considered indefinite term. You can't have that. So what we would apply here is L'Hopital's rule. So when we get into this form, we would say, since the limit, and we just state what the limit is. I'll just write sine x over x, but make sure you write the full term. Since the limit, sine x over x approaches 0 over 0, and the limit is indeterminate and differentiable, we can apply L'Hopital's rule. Alright, so what this basically says is that we basically have to state this. We're basically restating what we wrote. So I recommend doing this if you guys are taking some calculus class. These professors are usually they want to know what's going on. So just writing a brief summary can help for sure. So just write that on the side. Alright, so now what do? We have, it's 0 over 0. So what we would do next in L'Hopital's rule is take the derivative of the top and the bottom, essentially the derivative of the numerator and the denominator. So what is the derivative of sine x? Well, we know that's cosine x. Now, what is the derivative of x? We know that's 1. So this limit in turn just becomes limit as x approaches 0 of cosine x over 1. So now let's try evaluating this limit. So just plug in the values once again. So cosine of 0, that's equal to 1. And then as x approaches 0 of 1, well, that's just 1. So what this gives us is 1 over 1, and we know that's just equal to 1. So what we would then do is go back to our original limit right here and write limit as x approaches 0 of sine x over x approaches the value of 1. So the real answer here would be 1 for this equation. So let's clear this out and we can start a new problem. Okay, and also before we go into the next problem, the reason that L'Hopital works is because both the numerators and the denominators of the functions grow without a definite bounds. 0 over 0 and infinity over infinity, they're indeterminate forms. They aren't real numbers like 1, 2, 3. They aren't those type of numbers that you can easily find or easily evaluate. So this allows us to compare the rate of change rather than the actual values of the numbers, if that makes sense. Okay, so next problem, we're gonna start off again a little more easier and then make the problems a little bit harder. So the first problem is the limit as x approaches 2 of x squared minus 4 divided by x minus 2. So I think I did a similar type of problem in my limits video, but this and I solved it a different way. But this video is L'Hopital, so I'm gonna solve using L'Hopital. So all right. So remember, let's first plug in. So plug in wherever we have x approaching into for x in the function. So 2 squared over 4 and 2 minus 2. Both of those obviously get a 0 over 0. We know that. And that's the indeterminate form, and it's not, and it's differentiable. So we gotta state that. So since limit is differentiable and indeterminate, we can apply L'Hopital's. Okay. So now let's apply L'Hopital's. So now we can take the derivative of the top and the bottom. So derivative of the top will just result into x, and the bottom will just have 1. And we'll write the limit statement. Limit as x approaches 2 of this function 2x over 1, and that just becomes 4. So we would rewrite this, and it'll be limit as x approaches 2 of x squared minus 4 over x minus 2 gives us an approaching value of 4 for this limit. So that's how you would solve that problem. Alright, let's move on to the next example. If you guys would like more practice with these type of problems, I'm probably going to link a worksheet in the description that you guys can do, or in the comment section, just so you guys can check that out if you want. So our next problem is the limit. I forgot to write the statement. Just write the statements too in the last one. Yeah, I can go back and do that. Okay, we have here. Just tell them you applied. Tell the grader you applied the L'Hopital. So using L'Hopital's, we would get a answer of 4. Just make sure to be descriptive in like what you're telling your grader if you're in like a quiz scenario or anything. All right, now to the next question. All right, so we have the limit as x approaches 1 of natural log of x over x minus 1. All right, let's plug and chug in. So ln of 1, we know that's equal to 0, and then 1 minus 1, that's 0. So that's equal to 0 over 0. So again, just write the statement. This limit approaches an indeterminate and differentiable form. Apply L'Hopital's rule. Okay. Now we'd apply L'Hopital's rule. So this will become limit. Oh, let me fix that. Limit as x approaches 1, and the derivative of ln of x is equal to 1 over x. So in order to do these problems, you guys should have your derivatives memorized, over 1. And that gives us the answer of 1 over 1, which is once again just 1. So we rewrite the limit as x approaches 1 of ln x over x minus 1 approaches a value of 1. And then we would say, using L'Hopital's rule, we find the limit for this expression is 1. Alright, let's move on to our final example for today. Again, there's going to be a practice posted in the comments or description, so make sure you check that out if you need more help. Okay, this is a little more harder example and a different case of L'Hopital's. So we have the limit as x approaches infinity of x squared over e to the x. Okay, let's try plugging in infinity over infinity for both. So that just becomes infinity squared over e to the infinity, and we know that's just infinity over infinity. So that's L'Hopital's, right? So we would just write again our statement. Since the function is indeterminate and differentiable, we can apply L'Hopital's. So now let's take the derivative and do the same steps we've been doing. So this becomes limit as x approaches infinity of 2x over e to the x. Now let's plug in again, okay? So that just gives us infinity over infinity. So we have to reapply L'Hopital's here. So what we would say, we'd write another statement, right? Since this function gave us an indeterminate but rational form, we can once again apply L'Hopital's. So we once again apply L'Hopital's rule here. So limit as x approaches infinity of 2 over e to the x. Now if we plug in, we just have 2 over infinity, and we know that approaches 0. So our answer for the limit as x approaches infinity of x squared over e to the x is 0 in this case. And we'd write that statement using L'Hopital's. This limit approaches a value of 0. So yeah, that's how you would solve some L'Hopital problems. Again, if you guys need more help, check the comments or description for a worksheet. And yeah, thank you so much.